Today's tinkering is accompanied by black lager from Little Brown Jug Brewing in Winnipeg. The helpful tasting notes on the can suggest that it's unexpectedly light, dark in color, deep roast malt flavors, herby malty, and a clean, smooth finish. Those are all the things that I look for in a beer. So today I'm taking a look at a new microcontroller, at least new to me. It's a CHV003 family of microcontrollers. Even though they've been around for a year or more, I just became aware of them really from one of OneCircuit's videos, and I'll put a link to his blog article about it down below that's got a link to his videos and everything, where he did some experimentation with the 8-pin versions on a breadboard. So that's what triggered me to buy these, and I've been tinkering with them, and I think it's going to be a useful little chip to have in the arsenal. One of the reasons why it could be so handy is because the little 8-pin versions of these can be had for less than 20 cents a piece Canadian. That's like disposable prices or giving away prices if you're building simple little projects and stuff like that. You can deploy them all over the place and not be too concerned if they don't make it back to your home. Anyway, let's get started as I did when I was experimenting with it with these two boards here. So the one on the right is a development board based on the 20-pin version of the CH32V003. I'm going to get tired of repeating that part number over and over again, but regardless, that is the development board which breaks out a bunch of the GPIO. It has a 10-pin programming header on it, a button. The USB-C on here is only for power. It's not for programming. To program it, you use this board here, which is the programmer board. And it is also the same programmer board that you need for the little 8-pin dudes. Unsurprisingly, this one with a 10-pin programming header uses the ribbon cable to connect up to the programmer. I'm just making sure that, yeah, I have them in the correct orientation. Reset pin's in this corner here, and it's in this corner here. So when you plug that into your computer, that red light should come on, and it provides power over here. Apparently from my reading, this here beside it is a blue LED, and if it's on solid, that means this is in the wrong mode. And you have to hold this modes button down while you're plugging it in to change the mode. If that blue light is flashing, it means this thing's gibbled and you'll have to do some magic that I'm not going to get into, but I'll put a link down below to an article on EEV blog on how to get it back working again. Hopefully you don't have to go through that. Anyway, before we actually use this, and actually before I plug it in, I should show you just quickly how to get this thing set up, because it took me a little bit of time getting it set up on my computer. Now, I am doing this in the Arduino IDE because that's where I'm comfortable. There are other ways to talk to this thing which I am not going to be addressing because they're not where I'm comfortable, and that's not what I did. But if you're familiar with the Arduino IDE, you come into the Additional Boards Manager and you add this link here, which I'll have down in the description, which gets the board definitions. There's one extra step involved when you're doing this on Linux that I only found on this one blog, and again I will put a link to it down below. You have to run a shell script to set everything up, to set up the permissions for USB and whatnot. That is located in this path here, which is this shell script down here. I've already run it, but let's open it up and just see what it does. It basically just copies some library files, does some configuration, and creates the USB device rules and whatnot. No big deal, but it's something that you need to do on Linux that the Windows guys don't have to do because Windows doesn't have that level of protections on its USB stuff, I guess. Anyway, once that's set up, we can open up ye old Blink Sketch. I've modified this one slightly for the pin numbers, and let's go and take a look at that before we come back here. So since we're running the Blink Sketch, we want an LED, and it just happens to be an LED up in the corner here, which is labeled D1. However, that's not pin D1. It is, in fact, what is it here? That pin there, which is D4. So we have to modify our script a little bit, which is no big deal because you always have to modify your blink sketch for where your LED is, right? Right. So anyway, back to our blink sketch. This is just the standard Arduino demo blink sketch, but I've changed the pin numbers. PD4, pin digital 4, I guess. I'm not quite clear on why the pin definitions look like this, but they seem to be, maybe it's port D4. Regardless, that is what I've changed it to use that D4 pin that shows on the board. So then going into your board manager, you scroll down and find your board, which is that one there. WCH32V00, anything after that, which is cool. Make sure your serial port is correct, and then just upload like any other Arduino sketch. And there it's already compiled and uploaded. That took no time at all, but it's verifying. But once that verification is finished and it gives you an OK down here, which takes 30 seconds or thereabouts, we see we have a blinking light. That proves that the computer can talk to the programmer can talk to the board, and the board works. Now for development, that's not a bad board to use because it has a whole bunch of pins on it, but it's got a lot more pins than our little 8-pin chip. So that's our next victim, is to talk to the little 8-pin chip. Of course, an 8-pin chip, you're not going to connect it to a 10-pin interface, but that's okay because this thing has a neat trick. It allows you to do all the programming over a single pin. And that pin on the programmer is labeled Software Download IO. SWDIO. So we really only need 3 wires. We need voltage and ground. I'm going to use the 3.3 volts. You can use 5 volts as well. This chip is tolerant anywhere from 3 volts up to 5 volts. So it's quite versatile that way too. So there's our 3 connections on the programmer, the download pin and the ground and 3 volts. Unusually, the ground is on pin 2 and the positive voltage is on pin 4. Not used to seeing that arrangement on many chips. Normally, the power and ground are sort of on diagonal corners, or 1 and 8 or something like that, but whatever. This is a unique chip. Anyway, so I got the power and ground connected to it, and the download pin is on pin 8, so I'll put that there. Again, I'm going to have links to a bunch of different documentation and pinouts and whatnot down below, so don't worry too much that I'm getting carried away here. I guess we should connect an LED if we're going to run a blink on this, shouldn't we? Here's the pinout for the 8-pin. As I said, ground is on pin 2, power is on pin 4. This pin 8 can be a whole bunch of things, but that software download, software in-out is one of them, so I'm just going to leave it there. I could also use that as a digital pin, but I'm not going to, just because it might interfere with the programming. I am going to use pin D6 over here, which is physically pin 1. I could also use any of these other PA2, PC1, PC2, potentially PC4 as well, but I'm just going to stick with digital 6 for now. And put our LED onto ground and pin 1, physical pin 1, which is PD6. Yes, it gets a little confusing. Plug that into the programmer. We'll just quickly change that script and hit upload. And again, when that verify OK comes back, we should see a blinking light up here. There's our verify OK, and there is our blinking light. And of course, like any microcontroller circuit, once the programming is done, we don't really need the programmer there anymore. We can just hook up our power supply to it. It's set for about 4.5 volts. Power that on, and away we go. Very cool little chip. And like I said, as a 20-ish cent microcontroller, that and an LED, you're away to the races. But that's only using one GPIO. Let's go bigger. And I've already got that set up on another breadboard, so we don't have to go through all the steps again. This one, I've got 4 different pins connected. I've got physical pin 1, 5, 6, and 7 connected. And those are, again, PD6, as we were using before, and then PC1, PC2, and PC4. So here's my heavily modified blink sketch that I've got onto this second chip. I've defined up PC1, PC6, PC2, and PC4, as I showed, which are physical pins 5, 1, 6, and 7. I don't know why I didn't put that in order. Let's just go with it. Anyway, I have each one of them in turn. PC1 does a double blink, waits for half a second, and then PD6 does a double blink and waits for half a second. Then PC2 and then PC4. So I'm not going to make you watch me load that program again because I've already done that a couple of times. You've seen it. Let's just cut back to the desk and see it in action. So we'll just get some ground and some power from over there. And there is the 4 of these guys. You can see each one of them just blink, 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 blink. Blink, 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 blink. And again, they're just wired where they're physically convenient. I didn't do anything special. I didn't make them go in order or anything. And you notice that these ones are staying on when they're not being molested. And that's because I've got them connected to the positive rail rather than the negative rail, just for something different. I could flip them around if I wanted to. And a matter of fact, why not? Let's do a couple of them. So flip that one around to the negative rail. The reason that I initially did that, they're blinking like you would expect. They're off until it's their turn to blink. The reason that I initially did that is this chip has more current capability when it's sinking current, i.e. pulling low, than when it's sourcing current, i.e. pulling high, which is what it's doing there. But these are all staying well underneath its limits anyway, so it doesn't matter that much. Regardless, that's what I've done here. So now we have 4 digital pins to play with. And with 4 pins, you can do a lot more than just blinking 4 LEDs. You can blink 12 LEDs. Again, using the same 4 pins. And this is, if you haven't guessed it already, this is Charlieplexing. I've got a video that I did years ago on how you can multiplex using this method, and I'll put a link to that up there. It's tri-state multiplexing, and it is very handy for getting a bunch of different LEDs going. You could do other things too. You could put a shift register on there or any number of other stuff, but this is what I've decided to do just to demonstrate it. Let me show you quickly the code for this, and I'll ask you to excuse me right now because it is messy as hell. I've said it before, I'm not a programmer. I'm not really happy about programming, but I get by. So here's what I've got set up. I've got the 4 pins, PC 1, 2, 4, and 6. And there's their physical pins set up. Defined a whole chart of the various states. So when pin 1 is low and pin 2 is high, and pin 3 and 4 are set as inputs, which makes them be a high impedance, so they're not high or low, they're just floating in midair and not impacting the circuit. So when 1 is low, 2 is high, that turns LED 1 on. When you reverse that, pin 2 is high and 1 is low, and these two are like that, then the second LED is on, and so on and so on. All the way down here to the 12th LED. When pin 1 is high and pin 4 is low, that turns on the 12th LED. Before I go any further through the code here, let me just show you a quick schematic of this, so maybe it'll make a bit more sense, hopefully. So there's what we got wired up. There's LED 1 and 2 are connected between lines 1 and 2. LED 3 and 4 connected between lines 2 and 3. And then 5 and 6 are between 1 and 3. And that is what I had in that Charlieplexing video that I linked to earlier up in the corner. I just expanded this with the 4th line, so LED 7 and 8 are there between 3 and 4, one facing each direction. 9 and 10 go between pin 2 and pin 4, or control line 2 and 4. And then LED 11 and 12 between 1 and 4. So hopefully after seeing that, this little truth table makes a bit more sense. Anyway, we'll get into the main part of the code here. We'll set up names for the 4 pins just to make it a little bit easier to reference them. And then I just have this really ugly bit of code here. So to turn on LED 1, you turn line 1 on as an output and set it high, and line 2 as an output and set it low. So that turns on that first one. That is this state here. And at the same time, LED control line 3 and 4 are set to inputs. I don't know that you have to write them low because they are an input, but regardless, when you set them as an input, it puts them into a high impedance state so they're not impacting the rest of the circuit. For LED 2, we just flip those two around. The first line is low and the second one is high. Blink, blink. And then we wait again, LED 3, 4, all the way down to 12. Could you do this in a loop? Absolutely. Did I do it? No, because this is easier to read and easier to understand for a rank beginner such as myself. Regardless, there is my 3 introductory test circuits for this. A single LED blink is the obvious one that you're always going to want to do the first time you're playing with any microcontroller, just to make sure that you can talk to it, load the software onto it, make a sane little program. It's essentially Hello World, right? Sure. And then I expanded it just using, again, the guts of that same blink to blink 4 LEDs. And I got fancy over here, and there's a lot more to learn about this chip other than just digital outputs. You notice I haven't done any digital inputs yet. I haven't done any analog inputs. I haven't done any PWM outs. And this chip can do all of those things and more, but this stretched my brain enough for now. And for basic little projects, but yeah, it is a super cheap little microcontroller. The circuit board that it's sitting on costs more than the microcontroller. The LEDs probably cost more than the microcontroller. And as I said earlier, there is a lot more information about this out there. Not as much as you would like, and not all in one spot, but there are people that have been experimenting with it. And as I said, I'll put a few links to a few of them down below. If you got questions and comments, feel free. If you know of other YouTube channels or places that have talked about this thing, name them down below. Unfortunately, YouTube won't let you paste a link in, but if you name the thing, or if you want to send me an email and I will add it to the description, maybe that's a good way too. Anyway, yeah, thanks for watching. Questions, comments, other stuff down below. You know what to do. I will talk to you later.